All right, lesson 2, exponent laws and rational exponents. So the first part of this should be review, should be your third go around with exponent laws. And then we add a new twist in here when we talk about the rational exponents. So what's the goal today? Your goal is to be able to apply basic exponent rules. So that's what I said was a review from grade 9 and 11. Questions contain both integer and rational exponents. Now the rational exponents, that's the new component here. And that's what the challenging part of the lesson will focus on. And then I want you to be able to go back and forth with exponential and radical form, and you'll see how they all tie together in a minute. So the very first thing we're going to do, we're going to go through and talk about our basic exponent laws, and then we're going to do some examples with basic exponent laws, and then we'll move into the new concept of rational. So multiplication, rule here, when you are multiplying two bases that are the same, we end up adding the exponents. I've already done the proof in the grade 9 and grade 11 course. I'm not redoing proofs here. For division, it's going to look like this. When we have division, when the bases are the same, we subtract the exponents. Now keep in mind, I'll do this off to the side here, maybe in red. It can also look like this, a to the m over a to the n, so it can be written as a fraction as well. So keep that in mind, just a different form of division. Okay. Negative exponents. If I have a to the exponent negative m, I can get rid of the negative exponent by flipping the entire expression and changing the exponent, then becomes a positive. Or if we have a denominator that involves a negative exponent, by flipping it or moving it to the numerator, that term, the exponent then becomes positive. Power of powers, if I have a to the exponent m to the exponent n, power of powers simply says that we multiply our exponents together. And finally, that zero exponent, so any base to the exponent 0 is equal to 1. A couple of conditions here. And you can write this or draw this up however you want. Okay, first thing, the base a must never be 0. Okay. So a cannot be 0. And number 2, which I'll point out, is that rules 1 and 2, for rules 1 and 2, 1 and 2, the base must be the same. Base must be the same. All right, and that will get us caught up and let us run through some examples. So a couple of quick examples here. So all we're doing is simplifying, which means in simplifying we're trying to get it down to one variable in each expression. So for example, if I have 2 to the 7th divided by 2 to the exponent y, bases are the same, so we can apply division. If we are dividing, we are subtracting the exponents, so we end up with an algebraic expression in the exponent. So our answer for number 1 is 2 to the exponent 7 minus y. Okay. Second example. What happens if I have 1 divided by 5 to the exponent negative 2? It's a negative exponent, so the term that has the negative exponent, which would be the 5, we are going to move it to the numerator, and the exponent becomes a positive. So technically it's still a fraction. And what I put in green here you don't have to write. It's still a fraction, but there's only a 1 left in the denominator now. So we just write it as 5 squared. Third example. What happens if we have brackets x cubed multiplied by x squared? We need to identify that 2 brackets side by side means multiplication. Once we know it's multiplication, we're adding the exponents together, so we'll end up with x to the 5th. All right, power of powers. what happens if we have x squared y cubed to the negative 2? This is just what we call an extended power of powers. When there is no adding or subtracting inside the brackets, we distribute the exponent to each term inside that bracket. So our first step becomes x to the exponent negative 4. The y term gets the same exponent applied to it, so it's negative 6. This will get you full knowledge marks, but for communication, we can never leave a final answer with a negative exponent. So each term that has a negative exponent will need to move. So x to the negative 4th, it has a negative exponent, and the y term has a negative exponent. So that means that x to the negative 4th, we're going to move it to the denominator so that the exponent becomes positive. Similarly, the y needs to move to the denominator. We're never left with 0 on top. We still have a 1. So there's your extended power of powers. Fifth example. If I have 3 over b to the 4th, oops, let's put the square on the b there. Same idea. It's still extended power of powers, even though there's division inside. The 4 is going to be applied to the numerator. The 4 will get applied to the denominator. There is an exponent on that 3. If there's no exponent there, we assume it to be a 1. And each term has its exponent multiplied by 4. So we end up with 3 to the 4th divided by b to the 8th, 4 times 2. All right. Moving along here to the next example. If we have negative 6 m cubed n to the negative 2 and negative 4 m squared n to the cube, we want to simplify that expression. What will it look like? Remember that you can multiply like terms together and apply the exponent laws that apply. Now, that being said, the negative 6 and negative 4 are like terms. They are just numbers. So we apply what you've known for how many years? Negative 6 times negative 4. Negative and a negative, remember when we multiply them together, the result will be a positive. The m's can be put together. We're multiplying the m's together. It's multiplication, so we're going to add the exponents. So we get m to the exponent 5. And finally, the n's are like terms, so they can be multiplied together. And we'll have negative 2 plus 3, which will give us an exponent of 1. You don't really necessarily have to write that. You could have left it as m to the 5th. Oops, and just n. All right. Moving along here. The next example, would I leave myself any space? No. Okay, so 7th example. So I'm trying to match up some of the examples with the homework so you're not confused or frustrated. So let's go with 4a to the 4th b cubed divided by a to the 5th b to the 6th multiplied by negative a cubed over b squared. Okay, so some people are going to be a little concerned because there's a fraction. Please remember, fractions just multiply across the top. So there's two ways to do this. You could simplify each fraction first. So that's option 1. Option 2 is to multiply the numerators together, then multiply the denominators together, and then simplify it. There's no one better way than the other. Okay? So for this example, I'll simplify each fraction first. Not because it's better, but because it's just, I'm going to show both ways. So the 4, technically there's a 1 in front of the a, so 4 divided by 1 is 4. The a's, it's division, so I'm looking at my a values. It's division, so that means I need to use the proper operation here. So the numerator subtract the denominator, 4 take away 5, it's negative 1. The b value, 3 take away 6, is negative 3, multiplied by, and the second one, the fraction, there's no simplification that can occur. So, excuse me, we multiply the numerators together. So, to make the first term into a fraction, we put it over 1. Multiplying the numerators together, so that's this numerator and this one. There's a negative 1 in front, I guess, so you'd have negative 4. There's an a value, so a to the negative 1 times a cubed would give us a squared, and there's no b term in the numerator, so it would stay the same. The denominator, multiplying it together, 1 times b squared is just b squared. Simplifying that, we only have the b's to worry about, so negative 4, a squared, negative 3, so I'm just looking at my b values now. It's division, so I need to apply subtraction there. B to the exponent, excuse me, negative 5. Full marks for knowledge, but to get communication, full marks, anything that has a negative exponent, we need to move. So the b term has a negative exponent. So the negative 4 has a positive exponent. A squared has a positive exponent. B, though, needs to move to the denominator, and now it becomes a positive exponent. It's not the only way to do this question. No. There's going to be some people that are saying I can do that quicker. That's perfectly fine. I tried to show a bunch of steps there in order to help you out as you go through. I think I have time for one more example here. We'll just check. Yep, one more example. So one final example, which will let you get going with the first part of the homework. What happens if we have 2a squared b over, let's go c cubed to the negative 2 multiplied by a cubed b squared over c to the negative 4, and we'll cube it. So all I can say is what I would do, I'd simplify, get rid of the exterior exponents first. So my first job would be to get that negative 2 and the 3 distributed in to get rid of those exterior exponents. So I would end up with 2 to the negative 2, a to the negative 4, b to the negative 2, because the exponent on the b is a 1. C becomes c to the exponent negative 6. On the other side, I'm going to end up with a to the 9th, b to the 6th, c to the negative 12. What I would do now is multiply my numerators, because basically I have one term multiplying a second term. So I'm going to multiply the numerators together. The 2 doesn't have a partner, so it just remains the same. A to the negative 4th times a to the 9th. We're using our rules for multiplication, so we're adding the exponents. Similarly with the b, negative 2 plus 6 would be 4. The denominator, we need to add the exponents, so negative 6 plus negative 12 is negative 18. So again, full knowledge marks here, but in order to get full communication, you can't be left with negative exponents in your answer. It's just not proper mathematical form. So we identify the terms with negative exponents, and I'll just bubble them. So essentially you can think of it, they need to change locations. So that 2 to the negative 2 is going to end up in the denominator, 2 squared. A can stay where it is, because it has a positive exponent. B can stay where it is, has a positive exponent. The c term has to change location, and in this case it needs to go or move to our numerator. So there is your final answer. So what that will allow you to do, that allows you to do the first portion of the homework, and that's the review part here. This is just grade 9 and 11 concepts. We haven't got into anything you haven't seen before. That's the next start of the next video. So whether you want to continue forging ahead watching the videos, or you want to take a break and do the homework here, completely up to you. And if you have any trouble, I will help you during class. Good luck.